Hello everyone and welcome back. This is Bijan Kushia. Uh, the title for this chapter is MAC and port addressing. There are different types of addressing in a network. MAC, port addressing, and IP addressing. In this lesson, we are going to focus on MAC and port addressing. Hope you enjoy it. Thank you very much. Data generated on the sender side will be encapsulated with port addresses, IP addresses, and MAC addresses of the source and destination devices. Upper layer applications will generate data. That data is going to be sent down to transport layer. In transport layer, data is going to be chopped into pieces called segments. Each segment is encapsulated with source and destination port addresses. Segments are going to be sent down to network layer. In network layer, each segment is going to be encapsulated into a packet by adding source and destination IP addresses to it. Packets are going to be sent down to data link layer. In data link layer, each packet is going to be encapsulated into a frame by adding source and destination MAC addresses to it. Frames are going to be sent to physical layer to be prepared to put on transmission line. Destination port address will identify the application used by the source device to generate data. That information is useful to the destination host to know what application this data belongs to. Destination IP address determines destination network of the packet. MAC address will identify the recipient host on the destination network after data reaches that network. Client 1 is requesting web services from the server using HTTP. Therefore, it will assign 80 as the destination port address in its request in order to identify to the server that this request is related to HTTP. Client 2 is requesting email services from the server. Therefore, it will assign destination port address of 25 in its request in order to identify to the server that this request is related to SMTP. Both client 1 and client 2 use random source port addresses in their requests from the server. Client 1 would use port number 49152 as the source port address, and client 2 uses 51152 as the source port address in the request. Server is going to reply back to client 1 and client 2 by flipping the source and destination port addresses that were included in their original requests. For example, server is going to make port 80 as the source port address and 49152 as the destination port address in its reply back to client 1. And we remember, client 1 used port 80 as the destination port address in its original request. Server is going to make port 25 the source port address and the random port number 51152, which was used as the source port address in client 2's request, in here will make it the destination port address. Therefore, server replies back with the source port address of 25 and destination port address of 51152 to client 2. Well-known ports are reserved for services and applications such as web browser and email clients. Registered ports are available to those who create applications. The creator of those applications can go to the Internet Authority and ask for a port address for their application. Each application requires a unique port address. Dynamic or private port addresses are the ones that computers use as the source port address when they initiate communication with other hosts. Some of the well-known port addresses and their applications are listed in here. For example, Telnet is using port number 23. Telnet is using TCP protocol. Another example, SSH, Secure Shell, is using port number 22 and it is using TCP. TFTP is using UDP with port number 69. HTTP is using TCP with port number 80. These are well-known ports. Netstat is a Windows command that will list the protocols in use, the local and foreign IP address and port addresses associated with them. Combination of IP address and a port number is known as a socket. MAC addresses are 6 bytes long. They are 48 binary bits or 12 hexadecimal digits. The first 3 bytes or the first 6 hexadecimal digits are called Organizational Unit Identifier and are administered by IEEE to make sure that no two organizations receive the same. The last 3 bytes or the last 6 hexadecimal digits are unique within the same organizational unit. MAC addresses can be represented using dashes, colons, and periods. There are unicast, multicast, and broadcast MAC addresses. A unicast MAC address is made of a combination of 48 binary ones and zeros. It is used for one-to-one communication. A broadcast MAC address is made of 48 binary ones. It is used for one-to-all communication. Multicast is being used for one-to-a group within all communication. Multicast MAC address is driven from the device's IPv4 multicast address. For the multicast IPv4 address of 224.139.34.56, we are going to go through following steps to come up with the multicast MAC address. All multicast MAC addresses start with the following 6 hexadecimal digits 01005E. Therefore, we are going to replace 224 with those 6 hexadecimal digits. In order to come up with the last 6 hexadecimal digits of the multicast MAC address, we are going to convert octet 2, octet 3, and octet 4 of the IPv4 address into its binary equivalent. Then we are going to flip the 24th bit to a 0. Whatever the value of that bit is, we'll change it to 0. Then we are going to group the 24 bit that we have in 6 groups. Each group is going to have 4 binary bits in it. We are going to replace each 4 binary bit with its hexadecimal equivalent from the chart that we learned on the numbering system. Therefore, the multicast MAC address of the multicast IPv4 address of 224.139.34.56 is 01-00-5E-0B-22-38. PCBON and FTP server are in the same local area network. PCBON wants to communicate with FTP server. PCBON needs source and destination IPv4 addresses and source and destination MAC addresses. PCBON knows its own IPv4 address. We are providing the IP address of the FTP server. For example, we are pinging that server. Therefore, PC1 is capable of completing the packet and including source and destination IPv4 addresses in that packet, and send the packet to data link layer to create a frame by adding source and destination MAC addresses. PC1 knows its own MAC address, therefore it will include that under the field called source MAC address. Now PC1 needs the destination device's MAC address. PC1 first will check its ARP cache table. If that MAC address is already cached, it will use it and complete the frame and send it to physical layer. If it is not cached, PC1 is going to issue an ARP request. In that request, PC1 will ask a device with the matching IPv4 address to provide its MAC address in order for PC1 to start communication with that device. Since FTP server is in the same local area network as PC1, it will reply to that ARP request by providing its MAC address to PC1. PC1 is going to cache that MAC address in its ARP cache table and then include it in the field called destination MAC address in the frame and complete the frame and after that we'll send the frame to physical layer to prepare that frame and put it on the transmission line to go from source to destination. PC1 wants to communicate with a host that is located in a remote network. The process of adding source and destination IPv4 addresses is the same as the way it happened for local host communication. The packet gets to the data link layer. PC1 knows its own MAC address. It will add it as the source MAC address. It is looking for the destination device MAC address. It will check its ARP cache table. If it is not there, it will issue an ARP. Nobody in that local area network is going to be able to reply back because they don't have the matching IPv4 address. Router will take a look at that ARP request, realize that the destination device is in a different network than PC1, therefore it will return the MAC address of the default gateway of the network that PC1 is located in as the destination MAC address. PC1 will use that as the destination MAC address in the frame, completes the frame, send it to the physical layer to prepare it and put it on transmission line. Eventually router gets that. Router is going to de-encapsulate it, change the source and destination MAC addresses and forward it to the next router. The next router will do that, de-encapsulate and encapsulate it again with a different source and destination MAC addresses. This process happens until the packet gets to the destination device. Therefore, we can conclude that layer 2 addresses are going to be changed as a packet is traveling over a layer 3 device such as a router, but IP addresses will stay the same from source to destination. Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.